Hey guys, so this video is gonna run you through your post-lab analysis. We're talking about our discovering density lab that we collected data for yesterday. If you weren't here yesterday, please be sure that you copy down a partner's data and you just go with it, okay? Just in your journal, make sure you write whose data you took. Okay, so just kind of a reminder of what we did. You had to measure the mass of similar metals as well as their volume, okay? And then you had one different metal, okay? So I think first period, you guys are the only ones that don't have it in the 6th row. Everyone else should have it in the 6th row, okay? And so when you have your data table, you should have at least filled out the mass column and your sample volume column. Those things are probably the most important ones that you need for today. You are going to be graphing them. It's going to be important that you know your basic graph skills, such as your x-axis versus your y-axis. Okay, so just a quick reminder, y-axis is the one that goes up and down, x-axis is the one that goes side to side. When you have a title, it's always whatever's on your y-axis versus whatever's on your x-axis, and that's what I'll expect at the top of it. Yesterday, you should have also picked up one of these pages, or I handed it to you. If you, again, were not here yesterday, it's in the Wednesday folder, so you can just go grab yourself one. In this post lab, we're going to really pay attention to graphing today, and then you should be able to handle the post lab questions. I'll see if I have to give you hints on any of them, but for the most part, you should be pretty well. You should do pretty well. All right, so the way to use this video is pause it as much as you need, go back as much as you need, and just try your best on this, okay? Graphing is not everybody's forte, especially the beginning, and so just be patient with yourself and with your neighbor. Okay, so we're gonna go ahead and I'm gonna fill out my data table so that I make sure I'm gonna be ready to go, okay? And actually I'll do that on the next slide. So what I want to point out is what your end product is going to look like. Okay, so using your data that's in your table, your end product is going to look something like this. Okay, I need you to use up the entire page. I cannot stress this enough. Please use up the entire page. If you turn in a smaller graph, then I will deduct points. You want that much space so that you don't have as much error with your best fit line today. Okay. We are going to be putting volume across the bottom. So on our x-axis, that's going to act as our independent variable today. And our y-axis is going to act as our dependent or mass. Okay. Don't get bogged down with which one is really the independent and dependent, because the way you guys measured it, everything was pretty controlled. So looking at your axes, the one thing that's going to give everyone the most issues is going to be what numbers to put them, how far to space them out. The most important thing to me is that you have a 0, 0 in the corner, and you are going in equal intervals the entire time. So don't just skip 10 just to fit it on your page, okay? It's going to screw up your best fit line once again. I would use a pencil in this part and just, it might be trial and error a few times. I know I told a few classes to go through these two columns, right? To go through your mass column and to go through your sample volume column and pick out the biggest number. Once you have that information, now you can at least start kind of scaling out where you need to go. I think, on mine, I ended up going by about 2s where every single square. I only show the 10s, and that only got me to about, I think, 56. So it's your judgment call. I would try to make sure it's things that if you go in between the squares, you'll be okay. Okay. Okay, and then across the bottom for my volume, nobody's volume should be super huge. So you probably can all use what I have on the bottom. So I'll make sure that we use the same volume. Okay, and that is that Every single square will be 0.25. And then I'm only showing it by the halves. So if you see, I went skip 1.5, skip 1, 1, skip 1, 1.5, skip 1, 2. So I think you guys can all do this one. So if you want to already kind of start getting that one ready, that's good to go. Another thing that's going to happen today is I am going to have you calculate your slope. Having our 0, 0, I am going to allow you to use that. Typically you wouldn't, but we are going to use that one. We're going to do y2 minus y1, x2 minus x1. Some of us, this is super familiar. Others might not be. So feel free to ask your partner for help if you think they know what they're doing, okay? And then we're going to transfer that into our slope-intercept formula, which hopefully will allow us to figure out our densities. And you're going to compare it to the little chart that you guys have. Let me kind of move this over. Let me shrink. You'll see it on the next page, but you have a chart that's right underneath these instructions. You're going to compare it to that, and that's going to give you your percent error. All right, so let's just move on. Let's get this. Okay, so running through the steps, we're going to look at them each one by one. So this is after you recorded all your data, which I have mine up here. You'll label a new section called data analysis. So go ahead and title a brand new page data analysis. And we're going to be using up the entire page. I can't stress that enough. The first thing we're going to start with is labeling our axes on our graph and writing our title, as well as making our scales on the side. So this is the part that honestly takes people the longest. And so just be patient, use pencil so that you can erase your scale if it needs to change, okay? So I'm going to go ahead and take a look at my data table first, because what's important to me is to know how big I actually have to get. So on my data table, 58.6 is my biggest mass and 7.5 is my biggest volume, okay? So just like I showed you on the slide before, I think we can all have the same bottom scale. So we're going to do that one first, okay? So what I'm going to do is we're going to slide over to this graph paper. And yours may or may not have a few extra squares than mine. I will try to expand as far as I can. Okay, so first start out by putting a title on your graph, and it's always going to be y versus x. And so on our y-axis we had mass, our x-axis we had volume. So my title, therefore, is going to be mass versus volume, okay? And you really want to have it at the very, very top of your page. I'm realizing that mine is a little lower than I wanted it. But yeah, so you want to put that at the top of your page so it's ready to go. You can also go ahead and draw your two axes as close to the edge as possible. You can give yourself maybe 1 or 2 rows, depending on what you like. And you're going to write volume, and our unit for volume is going to be centimeter cube. We're not going to use milliliters. 1 milliliter is a centimeter cube, so that's the assumption we're going off of. And then finally, mass, your unit is grams. So we have our stuff labeled. That's your first step, okay? The next thing we're going to do is now put those numbers on there. So I know that I have to get at least to 7.5. So along the bottom, I'm going to count each square as 0.25. So getting to 0.25, we're going to look at every single box as being 0.25. But I'm not going to label each one or else that gets really overwhelming. So I'm going to go ahead and skip one. This will be 0.5. I'm going to skip another one. This will be 1.0. So you can kind of continue along the bottom. Okay. So go ahead and finish out your little scale. I don't want to use too much time on the video, so I'm going to go ahead and finish mine and you finish yours, and then we'll meet back up in a second. Okay, so now we're done with that bottom x-axis scale of all our volumes. I had to expand my graph just one more box to get 7.5 in there. So hopefully you didn't run any issues there. So next is kind of the tricky part where we need to write our y-axis, okay? So looking again at your little table, mine goes up to 58.6. You're going to have to judge yours on your own. Looking here, I'm going to go ahead and count even the squares that I have. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21. So I have 21 squares that I need to somehow distribute. So that's sometimes what I like to do when I'm making my graphs is I round whatever biggest number that I have. I kind of round it up and I try to see what I can make happen basically. So if I have 21 squares and I had 58, I'm going to go ahead and type that in my calculator and see what I get. And so what I'm finding is that my boxes most likely need to go by 3s. I don't really enjoy doing that too much just because it's kind of an odd jump between the numbers, but I'm going to go ahead and stick with 3s. So what I ended up doing was like I said, I typed in my biggest number rounded up. So I did 60. I divided by the number of squares that I had. Okay. And I got about like 2.8. So I'm going to go ahead and round that up to 3. So every single square is going to count as 3. Does not mean you need to write in every single number. You're going to find an interval and you're going to space them out so it's not so overwhelming. So I'm going to go ahead and zoom in so I can start doing this. I'm actually going to turn mine sideways. Okay. And you go ahead and calculate yours and see if you can figure out what's going to work. Again, we're going to use pencils so that just in case we need to erase it, we will. So I'm going to start putting mine on my graph paper. So if this is 3, 6, I'll go ahead and mark those. So I have 6 here, 9, 12, 18, 24, and I'm going to continue my scale. You go ahead and do yours, and we'll meet back up again in a second. Go ahead and pause the video and finish your y-axis. Okay, so now I've officially set up my y-axis, and I just need to remember that every mark in between is 3. Okay, so let's see where we're at now. Let's go ahead and zoom in here. It says we're going to graph each point and label each with the format XY, just like we used to do in math class, okay? Do not graph, again, this says 5th, I changed that lab yesterday, so that will be your 6th. Different metal. Only the 5 that seem to be made of the same material. Okay, and you guys have all figured out which one was your different metal yesterday. So, when we go to do this, remember this is your x-axis, this is your y-axis, right? So these are all your x values. These will be your y values. So these are listed first, and these are listed second when you're making your ordered pairs, okay? So I'm going to go ahead and start with my first one. My first one is 1.5 across the bottom, so I'm over here. Okay, I'll use a different color. Here you go. I'm at 1.5, and I need to go up to 8.62. So I know that this value right here is 9, so I need to go a little bit below that. I'm going to go ahead and do really close to the 9. So there's my point, okay? And then I'm going to write off to the side. I'm going to go ahead and put what it is, which is 1.5, 8.62. And that way I'm keeping track of what my different ordered pairs are. All right, and so I'm going to continue on, and I'm going to do another one with you, and then we will break out again to do it on our own, okay? So the next one, I'm going to go to 3.5. I'm going to go up to 29.23, okay? So 3.5, I'm going to follow it up to 29.23, so I'm going to get very close to this 30 right here, okay? And once again, I'm going to go ahead and write my little ordered pair right here. So I'm going to say 3.5 and 29.23. Okay, so go ahead and you start graphing yours. You should have 5 points at the end of the time, and then we'll meet back up again. Okay, so I've now graphed all 5 of my points and I've labeled them with my ordered pairs. So our next step is that make sure you do not connect your dots. We're not trying to play connect the dots here. We are going to draw a best fit line. So this is where you definitely need the ruler if you don't have one already. And you can share with a partner. So what you're going to do is we are going to use that little ruler. So let me pull my ruler up again. Here's my ruler, okay? What we're going to do is we're going to take this little ruler and we are going to line it up with our 0, 0 mark, which is right here at the axis, right? So here's my 0. Oops. Let me write this real quick. 0, 0. There you go. All right. And so we're going to start there. You want to make sure it stays there. What you're going to do is you're just going to kind of play around with the ruler. You're going to try and make it represent most of your dots, okay? You might have 1 or 2 that don't end up on the line, and that's okay. That's what a best fit line is. Technically, a best fit line is like an average, if you want to think about it. It's the one that goes right down the middle, okay? Or a median, whichever. All right, so I have now lined mine up, so I'm going to go ahead and I'm going to use green. I'm going to draw my best fit line, or I'm not. Let me line it back up. Couple technical difficulties there. Okay. All right. So I'm going to draw my best fit line. I'm going to remove my ruler. And as you can see, I have a couple, like this one down here, and this one up here, and this one up here that actually didn't make it on the line, and that's okay. These two, I think this one might be a little off as well. I only had one that really actually made it truly on the line, and that's okay. Point is we are taking into account an average of our data, okay? So once you have that, okay, now we're going to take our slope of our line. And I'm actually going to show slope on the very next video. So there'll be 2 videos. This way they're not overly long. So this one got your graph drawn. That's awesome. That's half the battle. Now we're going to start doing some math. So make sure you have a calculator ready for that next video.